So we're going to calculate KSP using molar solubility data. Oftentimes when you have an insoluble material, you can throw that into a flask, just a small sample of it, a couple grams, shake it up, let it sit, let the insoluble material settle out, and not all of it's going to be recovered. Some of it will have in fact dissolved into the solution, and in this case we'll be making a saturated solution of silver chloride. Using that same methodology, if you take 1 liter and throw in AgCl, we find that 0.00192 grams of it dissolve. Pretty typical. So we're asked to do 2 things in this problem. 1, to calculate the molar solubility if we know that 0.00192 grams of the AgCl have dissolved, and then also to calculate the KSP value. So let's get started. So first and foremost, we always write out the KSP equilibrium. So in this case, AgCl solid is in equilibrium with Ag1 plus and Cl1 minus. And from that also we can write the KSP expression. So it will be the concentration of Ag times the concentration of Cl. So I'm given grams in the problem. I know that that's not super duper useful, so we're going to go ahead and convert that over to moles. So we are given 0.00192 grams of AgCl. We're going to use the molar mass to convert that over into moles. And that would be about 143.32 grams. When you throw that into your calculator, you should find about 1.43 times 10 to the, I want to say, -5th. And of course, that's in 1 liter of solution, so that is actually equal to the molarity of the AgCl. So if we know that the molarity of the AgCl that has actually dissolved in the solution is about 1.43 times 10 to the -5th, according to multimole ratios, the molarity of the AgCl should be roughly the same then as the molarity of the Ag, since there's a 1-to-1 molar ratio, and the same thing then would be true for the Cl. So then we know the concentration here should be 1.43 times 10 to the -5th in both cases. So when they ask to calculate the molar solubility, that's really what this is. Molar solubility is really just a fancy way of saying molarity. So we've actually accomplished objective number 1 just by converting the grams to the moles. To try and accomplish goal number 2, to calculate that KSP, we need to plug in the molarity of the Ag and the Cl into the KSP calc and just finish it out. So we should have 1.43 times 10 to the -5th squared. And the KSP value here should equal about 1.8 times 10 to the -10th. No unit, but that would be our final answer. So that's calculating KSP data from basically saturation data.